Back. Sorry about that. So here we have AB, and we're going to try technique number 2 where we go the entire length of AB. And now to do that with the entire length, we make a big sweeping semicircle. Kind of similar to what we did before. And then we switch it over to the end point of B. Still the same length, of course. And we make a similar arc. I like using different colors because I think it shows up better. Highlight the points. Connect the endpoints. Or the points of intersection. And that, again, is the midpoint. That's technique number 2. They're very similar, a little different. We got one more technique to show you. But I'll wait until you're good to go. Okay, here we go. Now, in the third technique, for no reason, I'm just going to use a vertical line. Just to show you that it doesn't matter if it's horizontal or vertical. All these work for everything. All right, so on this one, let me move it to the top of the screen so you can see it a little better. On this one, it's a little bit like the first one, so we're going to go over halfway. A little bit more than halfway, and I make an arc to the left side and an arc to the right side. And then I do the exact same thing from the other end point. An arc to the right side and an arc to the left side. I like that. That looks like 2 X's. An X over here and an X over there. So there, I'm not making the full arc. Sweeping arcs. Let's highlight those points of intersection. You have a question? Connected to?
I think I'm exactly halfway, not
Oh, okay. Connect these. And then once again, that is called M because it's the midpoint. Now, I have not mentioned this, but you should know that these are all 90 degrees. If they're 90 degrees, that means they are, a mathematical term, perpendicular. I'm not going to expect you to know how to spell it. We don't really spell it out very often, but that is how you spell it. The symbol that we use for perpendicular is an upside down T, which I just showed you right here. So, putting it all together, what we've really constructed is a perpendicular bisector. So in all 3 cases, the red line on my constructions are what we would call, that's a perpendicular bisector, that's a perpendicular bisector, and this one's a perpendicular bisector. That is the construction number 3 where we bisect a segment. All right, is everyone okay with that? Addie, you good? Matt? Good? Landon? Johnny? Lauren, you all right? Emily? Okay, so let's move on now to some applications of this. Here's the first one I want to take a look at is, what if I wanted to come up with half of 3 AB? half of 3ab. Now, let's look into this a little bit more. The word of in math class usually means multiplication. So it's 1/2 times 3ab. And then we multiply by fractions. 1/2 times 3 is 3/2 ab. So half of 3ab is the same thing as 3/2 ab. Those are equivalent statements. Got it? All right, so we're going to do that construction. It's not that hard, really. Give yourself a segment AB. A little, it doesn't have to be very long. And then, of course, give ourselves a long ray, because we're going to do the AB 3 times. So there's AB, and then there's a ray. So that's the setup to our problem. First things first, we're going to do 3 ABs. That means we're copying a segment AB 3 times. Make sure I got the right length. The arc is the right on B, so I know it's the proper length. Now I move the compass down to the ray, put the sharp point on the end point, watch the screen. There's 1 AB. Then I move the sharp point where the arc and the ray intersect. Make another arc. There's 2 AB. Zoe, you following? Then I move it one more time. There's 3 AB. Lauren, does that make sense? 1, 2, and 3. You got it? Okay. I'm going to use a marker just to highlight the points, but between the orange marker points, that is representative of 3AB. Everyone see that? Okay. Well, we don't want 3AB. We want 3/2 AB, meaning we want half of that segment. So we're going to treat now this as a segment that we're going to find half of. Does that make sense? We have 3 techniques to use. We don't have to use all 3 techniques. Does it make sense? We only need to use one of them. I'm going to use the first one, meaning I'm going to put my sharp on the end point here and just eyeball it to make sure that it's more than halfway. That's more than halfway. I'm going to do an arc. It gets kind of busy. There's a lot of writing on there. Do it on both sides. I know that my end result, I need 2 points of intersection. There's one up here in that letter B. There's one down here. Use my straight edge to connect. That point that intersects with AB, 3AB is M. Now watch the screen. So I'm going to circle this segment that I'm circling right here is the length of 3/2 AB. Everyone see that? Did you do that on a quiz on Friday? You need to be able to. 3/2 AB. If you break it down and keep it simple, it shouldn't be that difficult. All right, we good? All right, let's go to the next application. All right, on this one, go ahead and make an acute triangle. It's got to be a little big, so just make sure that it's acute. Acute meaning that there are no angles which are obtuse. Okay, so there's an acute triangle. All right, now, Those of you that feel confident, you can work ahead. Okay? If you're not confident, I want you to stay with me. Here's what we're going to do. We're going to do 3 perpendicular bisectors. So basically 1 for each side of the triangle. That make sense? 3 perpendicular bisectors, 1 for each side. Here we go. Now, notice the first thing I did is I turned my paper, the orientation of my triangle, so this looks horizontal. You see how that side of the triangle now looks horizontal? It just makes it, I think, a little bit easier. All right, I'm going to use the first technique. You can use any of the techniques where it's a little bit over halfway. I'm going to make an arc like that. Go to the other side. Make an arc like that. Now, I really like to use different colors. If you have different colors, I would encourage it. I think it makes it look better and it stands out. There's those 2 points of intersection, 1 above, 1 below. Now I'm going to connect those 2 points of intersection with a different color marker. All right, 1 done, 2 to go. Everyone good? All right, now I'm going to turn my paper again all the way around so that this looks like it's horizontal. That's the orientation of the paper. I'm going to use the third technique on this one. You'll see what I mean when I say that, if you're following along with me. A little more than halfway. Just going to do an arc above, arc below, arc above, arc below. Basically, I get 2 X's, 2 points of intersection, 1 above, 1 below. Connect those 2 points. Two done, 1 to go. Turn the paper all the way around so that this is a horizontal orientation. A little more than, you know what, I'm going to do the third technique on this one, which means I go all the way out the whole length. Same thing here. Points of intersection above. And below. I'm going to connect those 2 points. Ooh, let me use the ruler. Look at that. Do all 3 points come together in 1 point? They should. That's got a unique term for geometry. When all 3 lines come together, they are called concurrent. That's how you spell it. Let me come around. Hey, look how you guys did. Okay, if you're not quite done. One done. Close. It does make a difference in reading. It does make a difference in different colors. You do, but don't change it. So whatever you do on this side, different colors. Nice. Different colors. Whoa. Different colors make a difference. Nice. Okay, so here's the next one. Those of you on the recording, hopefully you can hear me. Here's the next one. Do the same thing, but this time I want your triangle that you start with to be an obtuse triangle. So your original triangle is not a cube, it's obtuse. If you're not very confident, Zoe needs a little bit of help. Watch me, okay? All right, so we're going to go obtuse triangle. Make sure it's an obtuse angle. All right, so here we have an obtuse, because this angle right here is more than 90. Do you see it, Zoe? Okay, so step by step, let's do this one first. We're going to use the same technique, Zoe, that in all of them, all right? And for everybody else following me. So we're going to go from this point and make sure the compass is over halfway. You got it? Now, over halfway, and I'm going to make a long arc. And then keep the compass the same width. Don't let it move. Go from the other end point of that same segment and make a similar arc. Zoe, do you see there's 2 points of intersection? Okay, Zoe, I'm going to use different colors. You don't have to. You can use your pencil. Point of intersection there. And a point of intersection here. Do you see them? All right, now let's connect those 2 points of intersection. Zoe, you good with me so far? Okay, so now I'm going to turn my paper. Turn my paper so it's horizontal. You see this segment right here, Zoe? I'm going to do it again. Follow the same process. A little more than halfway. Go from both endpoints. Zoe, you got it? A little more than halfway. Highlight those 2 points of intersection. Now, Zoe, watch what I do here. I'm going to connect those 2 points, but I'm going to extend it so that it intersects the other line. See how I extended it out? Got one more to go, Zoe. Turn the paper so it's horizontal. Do it 3 times. Here we go.
This is not looking good. I didn't mean to. Now it's better. It's a little better.
Highlight the points of intersection. And connect. You see all 3 points intersect. Turn it back around to the original. All right, let me see your obtuse triangle. Notice where the point of intersection is. Should be outside the triangle.
Oh my God. Yes. It looks like I don't know. I swear. Yeah. I think it's if you were to hit him, it would have put together. I got a tiny one. Why is his so bad? YouTube. Now I know that like you're on
Okay, so a couple things that I want to point out before we leave here today. If you have a right triangle, now I think Harrison did one accidentally, but if you have a right triangle, that's okay. If we had time, I'd have you do it, but we don't. Right? So if we had a right triangle, and you did this whole exercise again, when you would find the perpendicular bisectors, here would be one dotted line. Here would be a second one dotted line, is this one. And then of the hypotenuse would be here. They actually, in a right triangle, they all intersect at a point still, so they're still concurrent, just like the other two, but they're concurrent at a specific spot. And that spot is at the midpoint of the hypotenuse. Now, interestingly enough, that point is also got a unique property to it. It is equidistant. That's a big word. It means it has equal distance. This point is equidistant to all three vertices. Well, since it's the midpoint of the hypotenuse, that makes sense. But it's also the same distance away from this vertex. Now, we actually don't even talk about that point. I'm not sure we'll get to it before Christmas. But the construction of it, we're already there. Right. All right, questions? All right, let me finish off this video, get it uploaded to Canvas. For the rest of you, we're done. For the
Like and subscribe.
Like and subscribe.